Good evening, ladies and gentlemen, and welcome to the first of the Royal Archaeological Institute's lectures for 2024. We had hoped to have Dr. Hannah Fluck speaking to us tonight, but unfortunately things have gone slightly awry. So I'm extremely grateful to Dr. Andrew Birley for having stepped in at the last minute. Andrew, as you probably will already know, has both his degrees from Leicester University. He is CEO of the Vindolanda Trust and Director of Excavations at Vindolanda and Magna. The topic of his talk tonight is very suitable, given that we're all under floodwaters and such like at the moment. His title is Last Chance to See, the Threat of Climate Change to Roman Vindolanda and Magna. Over to you.
Thank you very much, Lindsay. Thank you, everybody, for joining me. Now, let me just operate the system here and get the slides up. Here we are. Hopefully everybody can see this. So yes, thank you for the introduction and the opportunity to talk to you all this evening about the last chance to see the threat of climate change, Roman Vindolanda and Magna. One could have an alternative title for this, which is There's No Such Thing as a Truly Sealed Archaeological Environment. And this is one of the things that we're going to talk about this evening, how the old concept of if it's buried, it's safe, if archaeology is hidden, it's protected, may no longer be as true as it was in the past, if indeed it could ever be described as being completely true in the past. And that the threat of climate change, which affects things above ground, unfortunately is having a considerable impact on the buried archaeology, not just of what's going on in the UK and Roman Vindolanda and Magna on Hadrian's Wall, but also in a wider context too, right across global archaeology, because of course climate change is a global threat. We'll start off by just reminding ourselves where Vindolanda is. It's part of the Hadrian's Wall frontier system, and you see the black line across this slide here represents the line of Hadrian's Wall. And Vindolanda here sits where the red dot is on the map, halfway between the Solway Firth and the Tyne on either side of the country, and Vindolanda is in the middle. It was founded before Hadrian's Wall was built at about AD 85 as a Staingate fort. The Staingate was a Roman road linking the towns of Corbridge, around about here, and Carlisle here. And this little red line marks the line of the Staingate Road, more or less as we think it ran, linking the two major routes back north into Scotland together. In the 3rd century, Vindolanda was given its last Roman fort. And here we see an artistic impression of what that fort might have looked like, built by the 4th cohort of Gauls. And in stone, this is one version of what Vindolanda may have represented. But under the stone remains of the site, which is what you see if you visit the site today, and this is an aerial photograph taken just a couple of years ago, what you have is a completely hidden archaeological environment of many different layers. And on this slide here, I said 13 significant levels of occupation from the 1st to the 7th century exist at this site and in this landscape. What's more, in certain places, the top of the site here and the stone buildings of the 3rd century fort built by the 4th cohort of Gauls and its extramural settlement hide up to 7 meters of archaeological deposit, which is quite incredible, that sort of depth. The build-up of fort after fort, building after building, with each new layer being put down as a foundation for the next building above, creating an effective seal between the air that we breathe today and the very deep archaeology buried under the ground. Or is it a seal? Does that seal still exist? This is one of the things that we're going to discuss in the talk at the moment. Of course, Vindolanda is part of the World Heritage Site, the frontiers of the Roman Empire. And because of that, it has layers and tiers of protection and scrutiny because of that sort of status, because of the preservation of the remains and the wonderful artifacts that have come out of the ground. And one of the things we're going to discuss this evening is we're going to look at some of the things that have come from this site and think about those in terms of what may be happening to this site through the threat of climate change and what may be going on in the future and what may no longer be surviving in 10, 15, 20 years' time, and how that process is happening, and how do we monitor that? Those are all sort of themes that are going to come out in the talk this evening. That almost unique preservation at Vindolanda has given us an incredible wealth of information. And when you get underneath the stone buildings, like the ones on show here, which are part of the 3rd century extramural settlement, you've got the big earlier barracks, which are reused as townhouses in the 3rd century. And under their foundations, you see the mass of dark earth and soil, wet earth, covered in water. And in there, you've got wooden buildings, textiles, leather. And the first thing that you see when you uncork this material is the black earth, the black soil, the anaerobic deposits. You see it and you smell it. Because when you uncork this material, all of your senses are assaulted. This incredibly rich soil starts to rot for the first time in 2,000 years once it's exposed to the atmosphere, once it's exposed to oxygen. And oxygen's a key ingredient that we're going to discuss this evening. And that turns the earth black and gives off gases, which you can smell straight away. So when we uncork a trench like this, when we take that protective seal away, the first thing you notice is the smell. And that's whether you're 20, 30, 40, 50 meters away, you notice sweet, sickly smell, and that's things starting to rot for the first time. But you see from this image, the wonderful wattle and daub fences preserved under the ground at the site, only a meter or two below the surface, the current surface of Vindolanda. A closer look at those fences show you the intricate weave of the wattle and daub fences and this silver birch still surviving, stuck to the edge of the trees as they were cut down and used to weave those fence lines. Now, amongst this dark, wet or moist material, which is in a very low oxygen state when it's preserved under the ground, there are some incredible range of artifacts which have given us so much information about the history of the Roman army, the northern frontier, Roman Britain, and really helped to put Roman Britain on the map. These include beautiful, delicate things like wooden combs, like this comb here that came out of the excavations at Vindolanda this year, made of balsa wood, very, very delicate wooden artifacts that have been shipped from the center of the Roman Empire, probably in this particular case, boxwood rather, probably particularly in this case from somewhere like Greece, and has traveled all the way up to the site before it's been deposited in the Vindolanda mud and then covered over by subsequent building layers on the site. Things like this wonderful toilet seat that came out in 2015 from the excavations. One of the only preserved wooden toilet seats from the whole Roman Empire. I think there are 3, one from Tasgetium in Switzerland, one from the south of England and the famous Neatham's feet or splinter, and this, because there's not much surviving, and this great example from Vindolanda. Now, okay, why is this amazing? Well, it's amazing because it's preserved and it's made of wood. And of the millions and millions of examples like this that must have existed in daily life, under normal conditions, under normal preservation, they haven't survived in the archaeological record through to us today to look at, to analyze, and to think about. And that's the gift that sites like this can give us if they are well preserved and if we can look at them in the future and analyze this material and gain the information from them. Surrounding things like the toilet seat, in that rich soil are all the wonderful microbes and, of course, insect remains surviving in the soil. And here's just a couple of examples from a few of the insects that came out of the excavations and the deep levels, the very deepest levels this year, courtesy of Katie Wise-Jackson of Dublin University, who's doing the analysis of the insects from the site of Vindolanda this year. And we see on the left there a wonderful little fly pupa, and on the right, the remains of a little beetle. These are almost microscopic. You can't really see them very well with the naked eye, but they're full and surviving and rich in the soil, but they're also incredibly delicate. And they're some of the first things to go if the environment under the ground changes. You lose straight away this sort of information. Now, I suppose some people may say, why? Well, so what? So what if you lose evidence of flies or beetles or other things? But actually, this sort of data is vital to tell us about the living conditions and the environment to which people lived in these spaces and places 2,000 years ago. How clean were their lives? What sort of things did they suffer from? All of that is preserved in the soil. The fleas, the bed bugs, they're all there in the soil if you get these incredible layers of preservation. Other daily artifacts like this leather workers all came out with a wooden handle last year, again because of the preservation. And of course, the Vindolanda writing tablets are perhaps the most special thing to survive, the most delicate thing in terms of wood to come from the site. Letters that are arranged to about 2,000 documents now, thin strips of wood about the size of modern day postcards, covered in ink handwriting, incredibly fragile. When we find them in the ground, they've got the consistency of damp blotting paper. They're about the size of a modern day postcard. And when we get them out of the ground, we can't find them with a trowel. We have to use a spade. We have to pull out the blocks of earth in a big clump and very carefully tease that material apart with our naked hands, applying a bit of gentle pressure. And then if you're lucky, as that block of earth comes apart, you get a letter like this Octavius to Candidus document on the photograph looking back at us. And this gives you the wealth of information, the richness, the direct connection to people's lives, their desires, their dreams, their aspirations. It starts to answer some of the questions you would like to ask an individual person should they be alive today. They tell you how happy they are, how miserable they are, what they're doing, what they're shopping, what they're buying. These are the sort of details you couldn't get from any other source, yet they're incredibly fragile and very sensitive to minor, never mind significant changes under the ground. Their preservation is on a knife edge. The Roman boots and shoes that come from the site, like these ones here on display in the Vindolanda Museum, or a closer look image of a few boots and shoes that came out of the 2017 excavations here, have revolutionized our view of what military communities were like 2,000 years ago. They've questioned the idea of a male preserve when you find things like this: children's boots and shoes inside military barracks, on the floors of buildings, inside forts from 2,000 years ago, from a period when we know that Roman soldiers couldn't legally marry. And we've always questioned how diverse or mixed communities may be. Well, this sort of evidence surviving helps us to answer those questions. And if we lose things like this, then we're so much poorer for it. We limit the sort of questions we can answer about the past. And of course, other very, very fragile things that come out of the ground: textiles, items of clothing, everything from this little insole of a shoe to a child's sock to other bits of rags and clothing, where we can analyze these items and look at their weave, the wool, look at the DNA of the animal. Is it goat? Is it sheep? How the whole methodology of making these fabrics and materials. It tells us so much about daily life, trade, industry, fashion, all of those things which are potentially lost if you get sometimes the smallest change in the environment under the ground. What you're looking at here is one of the last textiles to come from Vindolanda. It was found in 2018. We haven't found a textile on the excavations in the last 5 years of the site, despite the fact we've been looking in areas that should be full of them. But in the preceding 40 years or so, or 45 years of excavation, from Robin Birley's work in the early 1970s up to about 2015-16, there are over 800 textiles that have been recovered from archaeological deposits on the site, from the similar sort of spaces that we're working in now. But they're no longer there because they're one of the first things to be affected by changes in the chemistry, the biology, in the atmosphere, under the ground. They're very, very sensitive to change. So how do we see this physically on the site? What does it look like before we get to the scientific element of actually monitoring what's happening and getting some hard data to back up our physical or visual observations? Well, to answer that, we're going to look at this particular part of the site here, an area inside the 3rd and 4th century fort, an area that we've recently excavated adjacent to another quadrant that was looked at in 2017. So realistically, over the last 5 or 6 years, the whole southern part of this 3rd, 4th century fort has been examined, and underneath those stone walls, layer upon layer of timber buildings below and preservation layers have been examined. Now, in that space, unlike the dark soil that we found in the past, we found a very bleached and barren landscape. These are the photographs from 2022 and 2023. And what you see here, the little white dots mark the positions of timber posts. We've lifted the floors here of 3rd, 4th century buildings. We've taken up the clay cap, the foundations of those later structures, and we founded a desert-like environment underneath, sandblasted, arid. And in this space, different things have been happening which have started to rot away very, very quickly the Roman remains that are buried in the sensitive environments under the ground. And I'll show you those processes as we go through this presentation. Of course, it's not just a lack of water that causes this problem. And it's important to stress this at this point. Although what you're looking at here is evidence of desiccation of certain layers, what we're having, because of the extreme temperatures, most likely that we had in 2022 and a period of very dry weather in May and early June in 2023, we're also getting extreme waterfall as well. Now, over the last 150 years or so, there hasn't been a huge quantum shift in the volume of rain that's landed in the UK annually. But the way in which that rain is delivered and the way in which temperatures and heat waves have come about has started to shift. And that's having quite a dramatic effect. One of the effects is that wattle and daub fences, like the one I showed you earlier in this presentation, which was standing 30, 40 centimeters high in places, have now shrunk down in size. These fences are retreating down their post holes. The uprights are retreating down their post holes, and they're retreating rapidly. Everything is being compressed. And as the anaerobic layers lose their water density, and as they compress, then the heavier earth above compresses, and the whole ground, the whole landscape starts to shift. And as things compress, then the gases and the other materials are let out of the ground, and that compression multiplies again and again and goes deeper into lower and lower layers. And ultimately, you lose the first 2 or 3 timber layers and parts of the site through this process. And the reason for that is that the post holes that are left behind are being created so quickly that the normal archaeological process that one might find when you excavate a site, where you find a post hole filled with either the rotting material of the post itself inside, giving you darker earth or different colored soil in the middle of the post hole, isn't allowed to take place. It's happening so quickly here that the posts are shrinking down their holes so quickly, they're leaving corridors of air, linking the anaerobic layers below this part of the slide here, the darker earth and a bit of leather on this post, to the aerobic material above. Now, on a site where you've had 6 significant timber forts and towns buried or built one on top of another, and layers of packing and effectively foundation between each one, you have hundreds of thousands of wooden posts like this. And if each one of those on the top layer starts shrinking or moving down its hole, its post hole, and leaving a corridor connecting the area below to the area above, you've got thousands of pinpricks or holes which are letting air, oxygen, minerals, bacteria, and also, yes, water, if you get torrential rain, straight down, linking one environment to another. And that speeds up the process of destruction on those early layers. It speeds up the nutrients, the changes in the ground that are happening to the preservation layers. Effectively, you're no longer jogging, you're sprinting to the end game, which is the complete destruction of the earlier layers of material. Because this effect cascades from one layer to the next. It goes down and down and down, and eventually parts of the site that are 4, 5, 6 meters deep will be exposed to this sort of activity taking place. It's just a matter of time. So instead of getting complete fences, instead of getting floors, instead of getting the sort of material one might find above the floor, the first timber forts, you're encountering things like this. foundations only. And the layers of occupation below, things like this lovely leather sheet, are in poorer condition. And the number of artifacts one might recover, the amount and range of material that you can recover, everything from environmental all the way through to those textiles, writing tablets, and everything else, diminishes accordingly as the oxygen and the minerals and the landscape changes through time. So to give you a stark example of this process taking place, I'm going to show you two shoes that have come from relatively recent excavations at the site. The shoe that's on the screen at the moment was found in the excavations last year, 2023, from a deposit which is dated from 105 to 118 AD, so just before the construction of Hadrian's Wall. It's a man's shoe sole, and on top of that shoe sole, which is in quite a poor state of preservation, you see the top layer of leather has rotted away. You can just about make out the imprint here of the uppers. This is obviously the top of the shoe and the various delicate lacework which would have gone around the boot. Now, 50 meters away from where this was discovered last year, in the 2017 excavations nearby, in exactly the same period of occupation, buried under the same sequence of events, the same stack of Roman forts and layers of foundations, in 2017, we found this shoe. Now, this is quite a difference in terms of preservation. And of course, archaeological landscapes are complicated spaces. You will get pockets of preservation in certain places and not as well preserved areas and others. But what we're looking at here is a representation of a wider theme that appeared right across the site over the last couple of years. So it's not just the wooden posts that are shrinking down their holes. It's not the fact we've lost the archaeological record of textiles and we're finding fewer writing tablets and documents, but things that are more robust like leather are also starting to degrade. And with that degradation, you lose information, you lose tiers of things that you can do with this material to analyze it, to try and find out, for instance, how was the leather made? What did the leather come from? What is the import or export of this sort of material? There are all sorts of trade, economy, fashion. There are many, many things you can answer with this sort of material, and you're starting to lose the range of questions you can ask as the preservation changes across the site, which is very worrying indeed. So how does this link with climate change, and how can we scientifically back up those observations which I've shared with you so far? How can I back up those claims that this is a climate problem rather than a different kind of issue that's happening at the site? Well, we'll look at that in detail now. Of course, we look at that right on the back of the news that came out yesterday on the 9th of January 2024 that we've just had our hottest year on record, global temperatures. Absolutely incredible. So that's the background, that's the context for the discussion we're having right now. And these are some of the maps that have been produced. This is the actual proof of air temperature, daily surface air temperature. And if we look at the next slide, this is a slide that we shared with the BBC last night on their news bulletin. We saw that in around about 200 days last year, we beat the average temperature globally for that day from the previous global high temperatures. And the area in red there marks the change, the significant, and it is a significant shift in an upward curve. Of course, this leads to one of the reasons I'm speaking to you tonight instead of Hannah, because Hannah is flooded out, a direct consequence of this sort of activity. And it's happening all over the world, whether it's in the UK, whether it's happening to modern homes, ancient properties. It has a huge impact for the management of country castles, churches, any historic building that wasn't designed and built for the climate it finds itself in now. It was designed and built for the climate it found itself in when it was being built. And it's done well to survive to this point. But as things change more rapidly, adapting buildings and structures and adapting our techniques on how to preserve and conserve and manage those spaces is going to become increasingly important if we wish to protect them for future generations, or indeed if we wish to learn as much as we can before they go. There are various different tools we can use to do this. And one of the tools that's been developed, and I want to flag this up in Hannah's honor, is the National Trust Climate Change Hazards tool, which is looking at various different metrics that can be monitoring what can happen across the UK. And this is mainly with above ground data. It's things that are happening above the ground rather than below the ground. So looking at temperature, or looking at things like this map here, which shows the north of Britain is the Lake District. Hadrian's Wall runs along here, more or less, as Carlisle. Vindolanda's just around about there in this space, Ballister Castle. And what we're seeing here is the future threat of storm damage in the area around the north of Britain, where parts of Hadrian's Wall lie, with the darker colours here in red representing high threat and the lighter colours lower threat. Now, this is storm damage, slope damage, all sorts of things from direct impact of heavy rainfall, drought, changing landscapes in terms of fauna and flora across those landscapes. And this is one way to look at data and to manage and to conceptualize models of how things might change at a site. Another thing to think about, and to think about quite carefully, is just the scale of the problem we face, particularly with anoxic or anaerobic or very good preservation layers across the UK. This map here shows us where the peat levels, the thick peat levels, are deposited in the UK. And those thick peat levels preserve, well, over 12% of our landmass and over 28,000 known archaeological sites in Britain, of which Hadrian's Wall sits in this zone here with significant peat deposits in the central sector. And we'll get onto this in a moment. But this is a fraction of what's likely to exist in this landscape archaeologically, dating from the Neolithic or earlier all the way through to modern times. And as those bogs and marshes dry and crack, they release carbon into the air, which increases the problem we face. And this reveals, exposes, and destroys the archaeological material below. And unlike being able to rewild a landscape, which can be done through ecological methods, rewatering can be done and other things, if you put enough time, money, and effort, there are successful methods that have been employed. Once you lose archaeology, that layer of history, you can't get it back. It's not a renewable resource in that sense. You get one shot. And so while you can restore a landscape, it's very, very hard to restore archaeology. And what's worse, perversely, some of the techniques that are used to protect bogs or to protect our other features, to rewilding or bringing in different species to protect a landscape, can introduce changes which can be very detrimental to the preservation of archaeology below. And there's a conversation, a really important series of conversations that need to happen between people who are interested in the ecology of landscapes and preservation of landscapes from an environmental perspective and archaeology, because there needs to be a meeting of minds here. And as we'll see in a moment, when you introduce different types of water, oxygen, or bacteria into a space, if you're bringing things in from a long distance to rewild a space or to look after it, that can have a different sort of impact on archaeology and how you manage those landscapes. So how does this condense into a wider picture? Well, the preservation of archaeological remains in situ, or the Paris Agreement, was established at the sort of response to the Malta Convention, the Valletta Treaty. Around about 1992 was the last serious update. And this was before climate change was considered as such a serious threat to archaeology across the world. And it's worth bearing in mind, since the mid-90s, we've had almost half a degree centigrade change in the average temperature to the world. So things are moving rather quickly. So agreements like that need to be relooked at globally before we think about our responses. So going back to Vindolanda, we've seen what's happening in the ground. Visually, we can see we're losing material. We can see some of those changes taking place. But how do we monitor it? How do we actually get some hard scientific data to back up those observations? Well, what we've done at the site is we've installed a series of probes deep under the ground going into spaces which we can't visualize when we're on top of the ground to give us information that we couldn't otherwise get. And we've tapped that in to a weather station dedicated to the site. So we get local weather, precise information from that, telling us what's happening above ground, and then linking that up with data that we're getting from below the ground. And we selected 3 parts of the site to do this, to effectively take a transit through the site, and we hope to add a 4th very soon, this year or next year, in this space here, so we can map what's happening subterraneously across the ground. One of those series of probes is going into this area here, which sits next to the main visitor path coming to the 3rd century settlement, and goes into a series of huge fort ditches which run underneath this part of the site. This little dot here represents a series of probes on the right-hand side being shown, being installed. They go into our Severan ramparts, which are over 1 meter thick in clay, boulder clay. Surely boulder clay is a great protector against the air above to what's happening to the archaeology underneath. Well, we'll see in a moment when we look at the data from that. And then the final one is going into the area that we've been excavating most recently. So we can monitor not only what's happening under the ground now, but also back that up with the archaeological data we've gathered from the spaces around the probe, the bacteria, the insects, the state of the leather, all of this sort of stuff coming together with the excavation and the post-excavation work to back up the data that's coming from the probes. The weather station itself gives us rainfall, rain intensity, temperature, humidity, barometric pressure, wind speed, wind direction, and the dew point temperature. Now that's a lot of information. We kind of possibly went OTT here, but at this point, when we put this infrastructure in, we were not 100% sure what it was we should be measuring, what exactly we should be getting back. But as we started to see the data come through, which I'm going to share in a moment with you, we started to refine that. And if I was advising somebody else to do this, there is a much shorter list of things that I would advise that you need to measure to be able to get some good indications on what's going on under the ground. So what are we measuring under the ground? Well, this is a little short list of the things that we're looking at. And here I have to give credit to my colleague and partner in crime, Dr. Gillian Taylor, Associate Professor at Teesside University, who's been working closely with me on this particular challenge. And we've got temperature, moisture in the soil, how wet, how moist is the soil, pH, which we'll see in a moment is vital for the preservation of different types of material, ground level water, what is the water table in the areas we're looking at, conductivity, how much microbial activity is happening under the ground. You know, all organisms are like batteries. When we live, when we breathe, when we do things, we create electricity. The more electricity down there, the more conductivity, the different types of materials and the different types of bacteria breaking things down tells us how active those environments and those spaces are. And then the redox, how much oxygen is in that landscape. And of course, in an anaerobic layer, you want as little as possible. The first thing we had to do was to dig a few boreholes across the site in which we could put the probes. And that enabled us, of course, to get cores which we can analyze, showing the material that we're going through. So we have a detailed understanding of what this material is and what we're going through. After that, we installed the probes, and each probe has its own little data hub, and it sends the information back to the internet, back to a server and a website. And every 15 minutes or so, we get a reading under the ground from each one of the probes, measuring each one of those things I described a little bit earlier. So what does this mean? Well, let's look in detail at a few different options here. Let's take pH for a start. If you get a decrease in the pH, it becomes acidic. As it says here, it can lead to jellied bones. It can dissolve ions in the soil. If it's too alkaline, your textiles and your leather artifacts will start to go. pH 7, around about neutral, is what we're looking at. And we'll also see that this has an exact link with the oxygen reducing potential, how much oxygen is in the soil. When we measure one, you can see how it affects the other. They are intertwined. So I suppose, now knowing this, as we'll show in a moment, if one was doing this on your own site or thinking about this in a wider context, you might choose one or the other, knowing there is an impact from one on the other. But I would still suggest measuring both, particularly if it's an anaerobic layer. So the oxidate reduction potential tells us what's occurring in the soil, and we want it to be reducing. But most of all, what you're looking for is a stable environment. You're looking for something which is the reverse of a little widget being attached to your finger in a hospital where you're looking for your heartbeat, your good oxygen level. What we're looking for here is a flat line or a very slow change under the ground. What we're getting is the opposite of that. So this slide shows here a depth of 1.2 meters under the ground. And this is the area around our Severian ramparts. This is the area that's buried under the clay. And we can see that we've got, as we go through the date at the bottom here, the various years. So we've got June, and we go all the way up here to December. We get a leap throughout the year in oxygen, and we get changes in pH at 1.2 meters under the ground, buried under that rampart clay, depending on seasonality and depending, as we'll see in a moment, on rainfall. The longer you stay above this line and you're in the ORP and you're in the red, the more oxygen's getting in there, the more oxygenating bacteria or bacteria that uses oxygen as a fuel is breaking things down, and the more dangerous it is for organic material in that environment. And of course, it's not just being in one zone or the other, being in the red or the green. It's the shifting between one and another, which causes a strain on things under the ground. Imagine you've got a piece of fabric and you're pulling it constantly, from stretching it from taut to loose, taut to loose. That's what's happening effectively, chemically and environmentally under the ground at this particular point in Vindolanda. If we go deeper in the same area, down to 2.4 meters, we get a slightly more subdued picture in terms of what's happening with the pH, and a slightly more subdued picture in what's happening with the oxygen reducing potential. In other words, at this particular point of the site, that extra meter and 20 centimeters of depth offers a modicum of protection to the environment below the ground. Things are changing, but they're changing not to as a great extent or not to as extreme extent, but they are changing. You're still getting huge fluctuations here in the amount of oxygen, and that effectively maps into the previous slide where you're getting longer duration of change, but slightly deeper down, you're still getting those changes happening under the ground. You're still getting those stresses and strains. You're still getting the introduction of different material, different bacteria, different type of environment. It's seesawing from one to the next. It's not a stable environment. It's being affected by the weather. Now let's look at that weather. Here is a map on the top, or a chart on the top, showing you the average rainfall of Vindolanda from the 22nd of October to the 8th of January. And the first thing that sticks in my mind when I look at this is how consistently awful the weather has been over the last 3 or 4 months. There's barely a day or two without any rain, and quite often it's significant. 10, 15 millimeters of rain. That's a lot of rain. There's a lot of it. And in the first depth of Severian rampart here, we look at the oxygen reducing potential. Green is good, red is bad. And we can see, although these spikes don't exactly line up, there are plenty of them over this period. And you're continuing to get dips and troughs as the ground responds to the elements above, the atmosphere above. Even though you're buried under over a meter of clay, it's not offering a permanent protection at this depth to what's happening in the climate above. If we go to the next slide, and we go to site 11, which is the Fort Ditch on the northern part of the site, we can see this even more starkly. And here we've got the relationship between oxygen reducing potential, which is on the top here. Green is good, red is bad in terms of preservation, and the pH. And remember, if it's too alkaline, you've got a real problem. You're losing leather, textiles, you're damaging wood, it's too acidic, you're getting a different kind of problem. And what you're looking for is stability. You're looking for, if there is a curve, a very gentle one to prove you've got a stable environment. But look at this. Look at the mapping we've got here, the link between the peaks and the troughs in one and the other. There is a relationship here between oxygen and what's happening to the pH under the ground. A chemical reaction as well as a physical reaction. And this will be partly because of bacteria and other organisms using that oxygen and doing things under the ground. And what they're doing, in part, is rotting things out. We take a time slice through the site and look at the stratigraphy of Vindolanda through the various different periods. We can see the different colors of soil on this slide coming down, all the way from the sort of humusy dark earth on the top with the oxygen rich, the middle slice of the site and its clay barriers, the dark preservation areas below. And our concern is that the colors at the top here, particularly this middle bland, will eventually come all the way through the site. And if you want to know if you've got a site that's well preserved and it has anaerobic or oxygen-free conditions, just doing a core of your site will give you this sort of information. You'll be able to detect very quickly what you've got through the colors, the smell, not the taste, don't lick it, but you'll certainly be able to pick up very, very quickly what you've got and the health of your site just by doing a simple core looking at this. And one method that you could do rather than constant monitoring, which is something I do advocate, if you've got the resources to do, is over a certain period of time, perhaps once a year, perhaps once every 2 years, taking another core in a similar area, as small as possible, to do a health check on how your site is developing or what's happening under the ground, if you haven't got all the equipment that we've got at somewhere like Vindolanda. So that's Vindolanda. But what about nearby at Magna, another site owned by the Vindolanda Trust? And to be honest, thinking about this, what about this whole central section of Hadrian's Wall and all the other Roman sites around about it that may be preserved under similar conditions? And if this is happening at Vindolanda, surely Vindolanda's not alone. It's happening elsewhere. And at the site of Magna, we've seen this also taking place. Here is the site of Magna, a Roman fort on Hadrian's Wall. You've got Hadrian's Wall snaking on in the backdrop of this shot under a hard frost. This is the wall ditch running through the shot and the vallum on the south side. And the platform here is the 3rd century fort itself. Unlike Vindolanda, Magna has not been subjugated to modern excavation campaigns up until, in fact, last year. Very little work at all had taken place on the site historically. But it is the sister site to Vindolanda. It's a Steingate fort site, has the same wooden sequence, then becomes a Hadrian's Wall fort. And in 1972, the Vindolanda Trust purchased the land around Magna, Carvorin, to preserve it, to land bank it, and to protect it from modern agricultural practices, to make sure that there was no fertilizers put on the ground. There were no more drains dug through the site, to effectively protect that landscape, to keep it as grass pasture land as long as possible. But over the last few years, we started noticing significant changes at this site too, really from 2015 onwards. So about a decade ago now. And those changes, to start with, were quite subtle. The field walls around here started to collapse in greater numbers. And that suggested to us that the foundations underpinning all of that material were starting to get very wobbly. And then this swampy marshy area in the north part of the site started to drop. And as it dropped, Roman features like a well here and other bits like a road and ditches and the fort ditches themselves started to emerge for the first time in centuries. They started to become visible in the landscape as the earth and ground moved. This, we knew, created a problem. Here on the left-hand side, we've got the earliest plan of Magna, the McLaughlin plan. I think it's 1857. Absolutely beautiful. It shows a peat bog in the northern part of the site and a little bit of a pond here in the fort of Magna with its junction of Roman roads at the bottom of the site. And on the right, the geophysical survey done of Magna in 1999 by Alan Diggins and Taylor. A really good piece of work showing you the extent of probably the 3rd century, 2nd and 3rd century settlement, the graveyard here, the town and the fort platform and part of a mile castle on the northern side, showing us there's plenty left there to be discovered in this landscape. The LiDAR survey, more modern, again showing you what an extensive Roman landscape this is, with the Mar Castle at the top, the Vallum, the fort, and then the Staingate Road linking the site to Vindolanda, coming through on the south side of the fort. The concerns about this landscape prompted the Trust to pull together a project to dig a series of small boreholes across the site, 2 in the bog, 1 in the vallum, 1 in the northern ditch, and 1 on the south side of the site to try and detect the strata of the site, look at the archaeological sequence, and try and see what was going on. So just like Vindolanda, those boreholes were dug, going deep into the ground, the one on the south side of the fort going 6.5 meters, cutting through or taking a time slice through about 5.5 meters of that anaerobic material. So incredible, absolutely a parallel to Vindolanda in terms of its potential for preservation and history and information. We radiocarboned some of those cores, and we found that the earliest deposits were 6,000 BC. Absolutely incredible, particularly around the lake area when this pond or lake started to form. But as modern climate has changed, that boggy marshy area has shrunk again and again over the subsequent years. And the bog itself probably started to completely silt over in the post-Roman period at about 700 or 800 AD. When we took those cores through, we found the moss and the peat, sphagnum moss. We could see the actual peat bog material building up that had protected the Roman layers below. And then we decided to install a proper station like Vindolanda. We call this one Wall-E because of its similarities to the Disney creature or character up on the left, to measure the sort of things we're measuring at Vindolanda, to give us that comparative data that we're getting from the site 7 miles down the road. Rainfall, temperature, air pressure, wind direction, pH, oxygen reducing potential, conductivity, groundwater level. Every 15 minutes so far, over 48,000 measurements. And by the time we get to the end of this year, over 1 million measurements from both sites will give us an incredible amount of data on what's happening under the ground. And what we're seeing at Magna is, of course, what one might expect in a certain way. Seasonality, like this, from the different probes in the different areas. Sorry, I have to keep moving the little widget around, which shows me everybody on the slide here on what I'm doing. But you can see what's happening in the spring, the summer, the autumn, at different depths across the site. And of course, naturally, just like Vindolanda, the topsoil is the most reactive to the atmosphere. Then, as you go deeper into the ground, slightly less reactive. The different layers, it does offer some form of protection, but it is not a flat line. You are getting variation and difference, sometimes large variations and differences through the seasons and in individual months. There's nothing stable under the ground here either. When we look at rainfall and temperature, we can map those too, and we can see the relationships just like we could at Vindolanda. And this all underpinned a short season of excavation last year to try and build up the sort of archaeological data that we have from Vindolanda in terms of a profile for the site of Magna. And the slide on the left shows you where the project will go over the next 4 or 5 years, the areas that we'll look at, starting with the Mar Castle at the top, the Vallum to the south of that, the bog or marsh area where the old lake used to be, the northern ditches of the ford, and the commanding officer's residence, to get an archaeological profile of this site to build up and match the data we're getting from the probes. The discovery so far included a well inside the Mar Castle with some good preservation at its very bottom, the remains of an old Roman shoe, surprise, surprise, a bit of rope and a tiny bit of timber being preserved, and buried outside the walls of the Mar Castle, a kist burial of probably late 4th century date. But this burial reminded us of the challenges we face at this site. It was in incredibly fragile state and very poor condition. You've got here a photograph and then a 3D model of the grave, probably a lady buried in that particular grave. Analysis of the bone is continuing by Dr. Trudy Buck at Durham University. And unfortunately, the bone was in such poor condition at this part of the site, we only rescued 27 to 28 animal bones on this particular one burial. And I think in 4 or 5 years' time, we wouldn't have got this. It would be gone. Such was the state of the remains. So it shows us how quickly things are changing at Magna as well, particularly in those first metre or so of material buried under the turf or the bog. The project will continue next year at the site, indeed for the next 2 or 3 years, gathering data and supporting the information we have from Vindolanda. But just to sum up on what we've been talking about today, because there's a lot to take in, I know, a lot of information. There are some key challenges that we need to think about and some key questions going forward. Some food for thought after this talk tonight. Well, the first one is really, I think, that we must surely now challenge the old adage, if it's buried, it's safe. It's not necessarily safe, I'm afraid. And this applies to a range of sites and spaces across our whole country and indeed across Northwest Europe and unfortunately the entire world. We now know what the endangered list of artifacts from Vindolanda and probably Magna include, and in the order that they're included, thanks to the archaeological work and also the monitoring that we're doing on the site. The first things to go are insects. The next are textiles. After that, you lose basketry and rope. Wood, especially the thin ink writing tablets, are the next things to go. And just think about that for a second. The information those 2,000 so far documents have given us on Roman Britain, if we lose those, if we hadn't been able to get them, how much poorer would we be in terms of our understanding of Roman Britain? And then after that, leather and bone. They're the next things to go. Beyond that, copper alloys that are very thin. Here we're thinking about decorative materials, some brooches, other bits and bobs are extremely vulnerable to the oxidization of the soil. They start to get effectively bronze disease and they become much more fragile in the earth. And speaking to Patricia, my mother, who has been working in the labs here at Vindolanda for 50 years now, she tells me that the quality of copper alloy work, the state of this material over that period of time has diminished significantly from the top layers of the site. So climate change contributes to more rapid degradation and sometimes, unfortunately, complete loss of archaeological material in sites. Now, as we can prove in the land that this is a problem, and we suspect more and more for Carver and Magna. And I'm going to leave you with a quote from a good friend and colleague, Dr. Richard Hobbs, and an article link here to The Guardian. And I think Richard wasn't exaggerating when he said this, that Roman forts near Hadrian's Wall are full of historical riches, and the climate crisis, unfortunately, is destroying them. It's certainly destroying some of them. Not everything will go, and not everything will go at the same time. But we have to wake up here. We're losing things, and we're losing things fast. Thank you.
Thank you very much indeed there, Andrew. You've certainly given us plenty of food for thought. And I'm sure the members will have questions. Ladies and gentlemen, if you do have questions, if you'd like to put them in the chat box, I will transfer them over to Andrew for him to answer as we go along. But can I perhaps ask one question? You were advocating that people with sites perhaps cord them occasionally to check the health of the site. Does not the drilling of the core actually interfere with the underground preservation and might actually make matters worse?
Yes.
How do you cap the hole you've made by boring into it?
There are methods you can do to cap the hole pretty much very, very quickly. There are compounds you can put in which seal the top. However, if you take a very thin, small core from a very big site, the damage you're doing there is minimal compared to what may be going on anyway. There is a risk. There's always a risk with any intervention that you make that you might slice through something, cut through something. In my own experience, when we did the core work at Magna, we had a problem with the core on the south side. We were drilling into something. But what the heck's this? This is causing us problems. We can't get down into this space, this lovely material that we're trying to see what's going on. It's because we went straight through the top of a cow's skull, and the skull was in such good condition that it basically rejected the core. We couldn't get through it. Yes, there's a risk. There is a risk. that you are going to drill in. I think the risk is greater that you're going to drill into something that you don't want to damage rather than being a conduit for the oxygen in the air coming in, as long as it's sealed,
Right.
and it's sealed very, very quickly. But I think the greater risk is not knowing, not appreciating, and not understanding what's happening on that site, having no information at all. And there's a blindness there that's the problem. The other challenge we face, and let's be frank about this, is the equipment that we've installed at Vindolanda, using the expertise of Van Walton, this list of wonderful people I've left on the screen here for you to look at, who collaborated with this project, and their expertise, which not everybody has available to them, is relatively expensive. It was £16,000 to do that work at Vindolanda. And there's a constant cost to it because we have to maintain the equipment. Somebody has to understand, know what that data says. You've got to learn how to read that information. You've got to maintain equipment. But there are certain things that you can do where you can do a quick check on the health of your site or the landscape that you're concerned about, which will tell you over a period of months or years, depending on how frequently you check, if there are significant changes going on. And the simplest is looking at the cause. There was an excellent paper came out several years ago now. It's got quite a controversial title. It's by Hans Husserman. I hope I've got that right, Hans. I apologize if I haven't. And Bertel van Os. And it's entitled "Relax, Don't Do It: A Future for Archaeological Monitoring." And it came out in the Journal for Conservation Management of Archaeological Sites, which is published by Routledge. And what they were basically saying in that journal is, look, you can do the sort of things that we've done at Vindolanda, and it will give you very detailed barrage information. And you can see then precisely, if you've got the right techniques, what's happening almost on a daily or an hourly, or in our case, quarter of an hour basis. And that's what we wanted, because we know how important the site is, and we know that the threat is real. We've seen it, and we need to understand it thoroughly because it's a complicated space. But if you just want to see, have you got this preservation in the first place? And I think that's an important question to ask. Is it there? Is it still there? Even if historically 50, 100 years, 20 years ago, somebody found something anaerobic or waterlogged in that deposit, is it still there? And the answer, unfortunately, in some cases may be no. It's already too late. It's already gone. And a small, inexpensive, quick core will give you an answer to that question. Now, what you do next, I suppose, depends on your budget, how important the site is, or known to be, and what you're prepared to do to try and really find out what's happening in that space and landscape. So what I guess I'm trying to advocate here is thinking through this in a very practical, pragmatic way, particularly for sites where we just no longer can be confident about the state of preservation under the ground because we haven't had a look in such a long time.
We haven't got any more questions are coming through, so I'm going to carry on. Chairman's privilege. Given that the bedrock is much higher at Carvoen than Vindolanda, does that mean that that site is more susceptible to climate change impact than perhaps Vindolanda is? And is that a matter of prioritizing sites which have got more depth of deposit or less depth of the deposit?
Yeah, that's a very good question. I think the Windsill Ridge, which is, forms the backbone of the central part of Hadrian's Wall, has quite a steep drop off on the north side, and a sort of gentle slope, if you will, or more gentle slope on the south, as you can see it when you visit the wall where it's upstanding. Subterraneally, it's the same. So there's a spine of that ridge which runs hidden under the ground, under the site. And yes, that particular zone is particularly susceptible to change because it doesn't have that depth of buried material. However, it really depends on the local conditions in terms of what's going on a particular site and management. There'll be parts of Magna which will be better protected than quite a lot of Vindolanda and parts that will go more quickly. And this is why when we've got such large management, such a large landscape to manage, our approach has been to take almost a transit through the site and do 3 or 4 small interventions. What I would never, ever advocate, and something which we've been careful not to do, is what we like to refer to as Swiss cheesing a site. Because I think if you do go to that point, then your first question would then become a serious concern. If every 3 or 4 meters you did a core, then yes, you would be introducing far too many variables into the site. So yeah, there's a whole host of different techniques you can use. One of the techniques you can use if you don't want to do anything in terms of ground penetration is now can do satellite work, and you can ask a satellite to fly over, and it will take a reading on soil moisture in the first 30 centimeters or so of the soil. You can ask it to do it once a day in the same spot, and that'll build up a picture. What it won't give you is what's going on much deeper ground. We're not there yet.
Yeah.
But there are simple signs if your site has other features on it which will give the game up. And this is what we noticed at Magna. So the ground dropping. Now it's slow. It takes, well, I say it's slow. It happens about 1 centimeter a year, which isn't so slow. But unless you walk frequently across that landscape, you may not notice it. But the well that's sitting in the field to the north of the site, north of the fort, is now, I think it's 86 centimeters above ground. And in the 1950s, you couldn't see it at all. It was invisible.
That's really interesting. Yeah.
The field walls collapsing. Now, this isn't just something that's happening at Magna, and it could be, but it's not in this particular case a livestock issue. We have the same livestock in 150 years, more or less the same sheep and cattle since the walls went up. Right across the national parks in our area, in our particular landscape, those old field walls are falling down at an alarming rate. And it's not just through a lack of maintenance. As any good builder will tell you, if your foundations move, your building's going to move.
Yeah.
And we're seeing that too. So there are those little signs that if you're observant and you're walking a landscape and you're looking at old aerial photographs and doing maps and surveys, those things will be picking up. There'll be little red flags, and from that, you can build a toolkit effectively, or a sensible path, which may ultimately lead you to wishing to do the core work. And if things are really changing rapidly, then to get a full handle on what's going on, you need to monitor. And the thing about constant monitoring is that it picks up the things that you might otherwise miss. And what do I mean by that? Well, if we just put this up for a moment, this slide for everybody. Back in 2003 to 2006, Dr. Jackie Huntley, myself, and Justin Blake, my former colleague, who's now a policeman, dug a series of cores at Vindolanda, and we went out once a month and we measured the water in those dip wells. And we took a reading on the oxygen and the pH and other things. But of course, we did it once a month. We didn't do it once every 15 minutes. And yes, we got some variation in the readings. But if it was torrentially raining one day, did Justin and I and Jackie go out and put those dip down the well and get soaking wet? No, I don't think we did. If it was snowing, definitely not.
Yeah.
I don't think so. So, just through human error or just being human, full stop, and being practical in that sense, we were missing things that were going on back then. We weren't picking up those changes. We weren't picking up the climate interacting with what was going under the ground so succinctly. And Jackie and I have a wry laugh about this because, we realized that was a mistake. But back in 2003 and 4, it was much more difficult to constantly measure. Now, piezometers these days, you can pick this equipment up for about £400, and that will tell you what the water level is going on in your site. And, they last 10 years. You can set a measurement up every hour, and it'll take a measurement every hour for 10 years, download it with a bit of free software, and then you'll know what's going on with the water level at your site.
Yeah. And
it goes up and up from there. But there are relatively simple solutions which I would advocate people look at first. But the first thing is look at that landscape. Is it changing? If it is visibly changing, then you know in your heart that you've got a problem that's developing.
Right. Well, Richard Neville has asked the $50,000 question.
Oh God.
Are there any measures that can be taken by heritage bodies to mitigate change?
Well, the answer, heritage bodies. Well, the answer is in terms of mitigation. Let's be frank and straight up. Um, on mass scale, and we're talking. I mean, let's just take the peat and bog areas. 12% of the UK, 28,500 known archaeological sites. No, it's too vast a scale that we're talking about here. Beyond the global effort of climate change. So I think the question, if I might be so rude as to turn that around slightly in a very political way, is not necessarily how we mitigate it, but how we respond to it in a different way, which is asking a very simple question. What do we want to know? What do we want to know from information that is not going to be available in 10, 15, 20 years' time? What do we want to find out now? What do we want to sample? What do we want to preserve the information from, even if the artifacts and the archaeology disappears in that period of time? It's awful for me to say this, but I think realistically, it's moving on from it's buried, it's safe, moving on from we can preserve every site. We can't preserve every site. There is not the will in the world, the resources, the manpower. It's not possible. This is a global issue. A different way to look at it is, well, okay, fine. If we've got this problem, we're losing this stuff. How do we then get as much information while we can based on those parameters? And I think that's where the conversation now has to go. In some places, yes, there will be things you can do. But for the majority of those sites, it'd be very hard because apart from anything else, archaeological landscapes are such complicated things, the way they've been formed from one area to the next. You may be able to apply a technique 50 meters in one direction, and you'll have exactly the reverse effect of what you're looking for,
Yeah.
30 meters the other side. So
Yeah.
be realistic. And what we need is government, officials, archaeological colleagues to start having this debate about with the wider public too. Because nobody owns history in archaeology. We all have a stake in it. We need to have an honest conversation. Say, look, it's affecting our past. It's affecting our present now, and it's going to affect our future. And we threatened with a form of Alzheimer's here that if we can't recall this information, if we think in terms of these are all photographs in the attic that we've left there in the hope that great grandchildren will pottle upstairs and have a look at those old photos and have a wry chuckle and work out who we all were. Well, if there's a hole in the roof, some of it's going to go. And do we want to make a photocopy of one or two of them now? I would suggest so. Yeah.
Andrew Selkirk is taking a historical view of this and is saying, is this not what Wheeler was saying at Stannick?
Yeah. I mean, when you look back, many pioneers in archaeology, and also in all fairness, in climate science too, ecologists I speak to, people who are meteorologists, have been saying to me, we knew this in 1995, definitely. We knew this. Nobody listened to us. Now, and I hate to say it, but they're being proved right. Now, it's not the same everywhere. Some sites will be more resilient than others, and we must be very honest about that. Some deposits will take longer to disappear. Some places may not move at all. But the most vulnerable are starting to disappear. We've seen this. We've seen this with Fenlands. We've seen it around, Cambridgeshire. We've seen it with Scar Car. These landscapes are going or gone in many places, and it's just a transformation that keeps cascading through. And no one particular time period is immune to this. Everybody who's an archaeologist who has a particular passion, your passion is equally under threat to everybody else's. So, as a profession, we need to listen to those voices and take this seriously.
I was also wondering when it came to preserving sites, I was thinking of many an archaeological site where a decision has been made to preserve it for the public, display it to the public, at a certain level.
Yeah.
Is there going to need to be a discussion about how one does that, whether one just puts down gravel or whether one puts down a solid clay cap or all sorts of things like that? Because it's not just the site's excavation, and it's what we've already got to see, which also may be under threat. If field walls are collapsing, then it's quite likely that some of
Yeah,
the
well, field walls,
preserved walls might start to change. Yeah.
field walls are collapsing, castle walls are collapsing, churches are moving, butters are moving. Yeah, you're quite right. And one of the things that staggered me, well, actually horrified me, to be perfectly honest, is the slide we're looking at, because I thought, okay, the reason I chose the Severan rampart, this is a huge clay rampart. It's 15 meters broad at its base. It's still standing over a meter and a bit high. Surely to God, if anything's going to stop the rain and everything else, I mean, we've always said clay it stops the air. It's part of the reason we have anaerobic in the first place, because of the natural subsoil the Romans just used. The answer to that question on a very fine level is it buys you anything between 3 days and a week per
Really?
meter of clay.
Only that much, gosh.
Yeah. What is
Right.
more resilient, and working with Tanya Romansky and others from Edinburgh University on their turf project, is turf, bizarrely.
Oh,
Turf,
really?
turf is the most resilient material we've discovered at Vindolanda anyway, and it's good news for the Antonine Wall. You know, it's very, very good at resisting temperature change. It's very elastic, and the way it's been laid down, typically, at least by the Romans anyway, but no doubt by other people too, lends itself to being able to, for that movement, for that elasticity, which really threatens the fabric of the materials. Turf can move. It can retain water for longer. It's got those lovely properties. But eventually, if it becomes exposed, it's toast. So,
Yeah.
I guess one of the questions we look at is the capping layer, you're right, and how thick that is, how resilient it is. And of course, once it's exposed, it's weathered, it's done. So this is one aspect that really needs more attention and more honesty, I think, with ourselves and with colleagues and with those who make up the rules and what we do. We must be careful here as a profession not to advocate something which is ruinously expensive and unrealistic. Will not be supported by the general public and can't be done. So we need to come up with strategies which, as I say, I think anyway, allow us to sample sites, allow us to get information from certain areas that may go or will go, so that at least we have that data. So in 20, 30, 40, 50 years' time, we've met our obligations to future generations. Because if they say to us, well, what was there? Instead of saying, well, something might have been there, but we couldn't be bothered to find out, we say, well, this is what was there, and this is what it looked like. And with the best techniques and technology we had at the time, which is pretty good compared to 10, 15, 20 years ago,
Yeah.
and I've lost enough hair now to be long enough to be able to say it, we can learn an awful lot. Of course, you
Yeah.
can always learn more in the future, but you can't learn more if there's nothing there to learn from.
Yeah. And Angela Rodden follows up with that with a comment. Presumably, this would also apply to the Stonehenge landscape. And she's thinking about the open letter that has just been published from archaeologists saying that explanation needs to be done.
Yes, in certain areas, I completely agree with you. Agree with that statement. And again, it's being proportionate. It's
Yep.
being selective. It's based on survey and as much information as we can gather from other sources. All those things remain absolutely vital. All those other non-intrusive tools need to come together to bear. Well, the landscape surveys, the geophysical surveys, all of the LiDAR, all those things, satellite, and then from that, and the core or whatever work you do, you take your slice and you throw the kitchen sink at that, and you get as much information as you can. And I think, realistically, that is possible for quite a lot of archaeology in the UK. And what's exciting about this, Lindsay, and for everybody else on the call, is that we now have such a broad profession, such a broad skill set, geoarchaeologists, scientists, climate science, all these people coming in, DNA, lipid analysis, oh my goodness me, peptides. all this stuff that wasn't available 20 years ago to give us some incredible results. And ultimately, if we could see our way through as a planet to do what we've done with the seed bank and have an archaeological equivalent, I think that would be a very good thing too. But that would require, international will to say, look,
Yeah.
this is who we are as a species. Let's record that. And I think that would be a very positive thing to do.
Right. Well, we have no more questions for the minute. So I'm very pleased that the Royal Archaeological Institute has made climate change a major topic for ourselves and a subject that will be influencing our policy for research funding and other matters in future years. So your talk tonight has been of particular importance to our members. You've given us a lot of food for thought, and I'm sure everybody at home will be clapping like mad to say thank you very much indeed, and particularly thank you for stepping in at such short notice as well. We've really
Well,
enjoyed your talk. Thank